What's up, guys? It's Wednesday evening out here in the backyard machine shop, your house of horsepower. Thought I'd do a little update real quick on the machine we brought in last week. Remember I was telling you guys I was looking to build a CNC machine to do some block and cylinder head work to help out here in the shop. And I came across this machine for $1,200. And last week I showed you guys, we just brought it in, got it all cleaned up and ran some wire to it, got it hooked up to my big phase converter in the back. We got a small rotary phase converter up here in the front shop to run some of the smaller equipment, but I have a bigger one in the back that runs the automatic screw machines and the two other CNCs. But anyway, ran some wire to it on Sunday and got it fired up. Had some stuck micro switches and a couple quirks, but for a machine that sat up for about 16 years without being used, I think we did pretty good. Got a little fixture we started setting up today. This is the angle plate off our cylinder head, our CBN machine. That's the machine we surface our cylinder heads on. And I removed that off that machine and setting it up on this, because tomorrow I'm going to start doing the programming so we can machine the top fuel hoops that we were talking about. I used to do this operation manually on the other Bridgeport, the other milling machine back there, and just want to get open up some capacity where we could do some things, programming and doing a little more precision, doing a little more speed up the process a little bit. But just right quick, I just wanted to show this for a minute, show you how far we got. We got it fired up. Let's go ahead and turn her on. Go over to startup procedure. Switch in the back, main power. Notice it's got a lube pump, just like a manual milling machine. It works on a timer, keeps it all pumped up. Got some fresh oil in that. Main start control on the side here. And this will fire up the control in the servo motors. And of course, recording it, it's going to show that it's blinking. I don't know if you just heard that thunk, but that was the servos coming online. And there we go. Welcome to Pro Macro. So this is a Fanuc control. This is after GE bought in stock with Fanuc. Fanuc, one of your original CNC control manufacturers from Japan. One of my favorite controls. I know a lot of guys have their preferences on some of the different machines, like Haas. Haas has its own control. I believe Fidal has its own. Fanuc was a company in Japan that early on put all their eggs in the basket of making machine controls and then selling the controls and the rights to use the controls to other machine builders. Primarily in the beginning, Japanese builders, some of the better Japanese builders. I think Makino was one of the first companies to come aboard with the Fanuc. Morisiki had Fanucs. Let's see. I mean, all your prominent Japanese heavy tool machine companies. And then the American companies, Pratt and Whitney had Fanuc controls. Monarch had Fanuc controls. And Fanuc's a mainstay to this day. Fanuc, which was just an abbreviation trade name, which stood for Fuji Electronics, which was originally called Fujitsu. Fujitsu Automatic Numerical Control was the abbreviations, what they came up with, Fanuc or Fanuc, or whatever you want to call it. I've always called it a Fanuc. But it's a plain G-code control. The Pro Macro is a little program to add some tidbits of conversational programming in, which I don't really care for. I straight G code. I'll program right here at the control, and it does have an RS-232, what we could link in to a drip feed or storage in and out to a laptop or a desktop computer. But you notice the machine is pretty quiet, not very noisy. Even the utility light came on. So we'll go ahead and zero it in, and I'll take you through the process of an old Vectrax CNC knee mill. Again, red top Fanuc servo motors all over this thing, and that's good. Those are the AC motors. The earlier, I think the yellow caps were DC, like my Morisiki had on. But anyway, this is a lot newer. This machine is a late 90s machine, and that's pretty new to me. But I think it's going to be a welcome addition here in the machine shop and help for Prince Brothers Racing. I got some big ideas of some projects I want to do when I get time, but right now I'm hoping it's going to help out here in the shop and basically help us make money. I had one subscriber message to me and say, "Stop taking on projects. You're always taking on more projects. Concentrate on what you already got at hand." Well, that would be nice to get some stuff done that we started on, but unfortunately, the only way I've ever been able to move up with equipment or progress would be to do it in a project form. Because again, you know, we picked this knee mill up for $1,200, and so far, so good. I don't think the machine had much wear and tear on it. Again, it's a box weigh machine. It's not a dovetail weigh, so it seems to be pretty stout, and the weighs are nice and clean. See, we're pumping some oil now. These has I think they call these the rule-on weighs. This is like a piece of composite material that lays over the weigh to protect it. But it doesn't look like to me she's got a lot of time on it. But so I'll go over the process. We'll go ahead and zero the machine in and bring the machine to home position. It's the first thing you do on a CNC when you're getting ready to get started. So we'll go over to our position page, and that's basically would be, you know, a generic way to call it. That'd be like your DRO. As you can see, your X, Y, and Z coordinates. Well, every time you turn it on, the machine doesn't know where it's at. So that's why you have to home it in. And homing the procedure in is to get the machine to trip the micro switches to tell it where it's at. Now, all the machine on all the axes have a micro switch for a home, and then an over travel soft stop. So when we first fired it up, and there's another one, there's the X micro switch, and on the end there, the two, the soft travel and the over travel limit switch. So all axes have micro switches. These were all gummed up, and the servos wouldn't fire up. That's a common thing. It was sitting, probably had coolant dry on them. The main one that was stuck was on the Z. Again, this machine, compared to a machining center, the head doesn't move up and down. This has a quill that comes in and out. So I had to take this cover off, and there were some micro switches behind here that I had to spray down with contact cleaner and lube them up and get them working. So, but it seems to be working now. We'll go ahead and home it in. First thing you do on this particular machine to home this one in would be to put it in the jog, and then we'll put it in high here. That would be our fastest travel. And the machine homes in to your plus numbers, X, Y, and Z plus. So you want to make sure you're off your micro switch. Right now, the Z would be at the home position. The spindle's all the way retracted. So to rehome it in, we need to bring it down some. So I'm going to go to Z minus, and we're going to bring the quill down. You notice that robust quill. At first I thought maybe I could set up a fixture to do some engine boring on here with the riser we're talking about building. But This is a lot larger than the Bridgeport. This is over a 5-inch diameter quill. So the only way I would be able to bore with this would be to use some long tool holders. And I don't think that's the way to go. So we'll still continue boring with our dedicated quick way boring setup over here. Basically a boring bore with the air float table. But I think this machine's going to be great for doing lifter bores. I'm going to do the O-ringing, top fuel hoops, maybe do some cylinder head porting, some other operations on the cylinder heads. I think even line boring by using the slim line right angle attachment. I think that's going to help out instead of doing line boring manually and then we finish them up in the line hone. I've showed in prior videos. Anyway, let's zero the sucker in. I'm getting off on too many different things. Let's go ahead and take it to Y minus. Y is the in and out. And let's take it to X minus. That'll be coming towards me. Minus will be over here to the right. All right, that should be far enough off from the micro switches. As you can see where it thought it was at 0, anytime you turn the machine off, it automatically comes back up on the display as 0. So we just moved it. You always want to move it a minimum of 2 inches. So now we're going to put it back in the home return. Put this on 100% on our feed rate. And we'll do the Z first. Remember, always go to the plus to zero in. Z zeroed. Now we'll do Y. And now we'll do our X. Trying to hold the phone so you can get a good idea of how this sucker moves. And you can see some of the silk screenings coming off this. It's like a membrane keypad. The older Fanucs had the bigger like typewriter buttons. I always liked those better. I always thought those were cool, the big plastic buttons. But they do make these. You could buy these keypads and replace them. It actually looks like somebody already replaced the top one because I remember using this last time. It was all coming apart. So they must have replaced the top keypad. That'll be something I'll look on eBay and replace this in the future. So now we're zeroed in, we're homed in, and that's going to step back and just look at the amount of travel this knee mill has now that it's zeroed in. I mean, it has a good bit of travel. It has 38 inches on X, that's long ways, and you can just see the amount of room it takes up there. So, I mean, as far as doing a cylinder head, you see where the center line of the spindle is now, where the head is, and how far that travels. Put a damn big old straight 6 head on there and go to machining. And the same with Y. The spindle is actually, you look at a perpendicular line with the table, it's way off the table. So it has way more travel than a conventional, say like a knee mill. I believe it has 16 inches on Y, 36 or 38 on X, and the Z travel is the quill. It has 7 inches of quill travel, but again, it's on a knee. See the locks for the knee there? So this knee also travels up and down. It could do it manually with a handle, but it also has a servo motor. I don't know if it's programmable. Some of these older machines, you were able to put like an M code in the control and travel that up and down. But this might be where you just set it manually, for your height, get everything lined in, and then just use the quill for your Z axis. But I was going through. There's a couple of programs still in here, and we'll go over, we'll go over to the program file. There's actually a program in there. And we'll go to edit. And here's the system edition. It's showing it actually has 1, 2, 2, 4, 6, 8, 10. There's actually 12 programs still in the machine from 16, 17 years ago. And I just called up a couple of them. And the machine's been off for so long, I just called up a couple simple programs that were in there, and I just kind of went through them, on what they looked like. They were simple programs. G43, turning the cutter comp on, just some linear moves, moving the quill. Like this program here, maybe it was cutting out a geometric shape, simple program. So I made sure that my part here is out of the way. This particular program, the Z was only coming down 125 inches, 125 thousandths. So it's nowhere near the cylinder head here. So what I was doing was, today, being we just got it fired up, I was just letting it cycle, just letting the lube pump run and run around, and let the electronics warm up and bring it all in the sink. And then tomorrow I'm going to go ahead and, I said we started fixturing this up. I'm going to write the program and we'll do the top fuel hoops. These are some Ford C3 Yates heads for a symmetrical port, small block Ford. This is I believe it's a power adder motor. I think it's a nitrous motor for a drag racer. I'm not sure of the setup. I know it's in a tube chassis car. But normally, like I said, I would have done this job on the Bridgeport back in the corner manually. We've done them on the Mazak. Again, the Mazak Machining Center is more dedicated for production. This is more of what I would call a tool room or prototype machine. So I think it's going to be really cool for a $1,200 investment to help us out with our block repair, cylinder head repair for customers. And like I said, I got some ideas in my head that if we get caught up, that I might tackle. I don't know, a custom billet Prince Brothers Hemi head might not be out of the question. Call me crazy, but it's something that's brewing in my brain. But so I will go ahead and run this program. Let's go ahead and we'll put it in auto. And program number 08888 is the name of that program. And got it on 100%. Let's go ahead and run it through. Cycle start, see what happens. So it's going in position, spindle's on, spindle's coming down. And we'll put this on program so you can actually see it reading the program, the lines is going down. And it's got a spindle head like a manual mill, belt drive, variable speed. So unfortunately you can't program an S code, you can't program your spindle speeds. You're going to set this manually like you would a Bridgeport. Here it's speeding up, it's slowing down. And that belt must be a little dry. It makes a little bit of noise so it warms up. And so those are your RPMs up there, just like setting a manual head on a variable speed knee mill. But it does have a 2-speed gearbox, and it goes as high as 7,200 or as low as 70 RPM. So it's got some nice spindle ranges, and that's where you go for your high to your low. I'll just back up here with the phone, and the drive axes are nice and quiet. And the quill's getting nice and lubed. I can see the oil's pumping back there. That's what I was letting it do today while I was working today. I was just letting it run, letting it cycle, putting the machine through its paces. Because it's, like I said, this machine has sat, I know, since like 2010. Again, the story was, it came out of a place called Dell Labs. It wasn't used much. Company went out of business, and a fellow I know acquired the machine. He has a manual machine shop. It was basically his first CNC. He couldn't figure out how to run it, and I actually rented the machine for a job I had at the time when I had my tool and die shop, and I went over there and used it and made some die plates on it. After that, I tried buying it from him. We couldn't come up with a price, and he sold it to another guy in town, a guy by the name of Thompson. He had a little workshop. He wanted his first CNC. He bought it, and when I started thinking about trying to find a machine, again, one of the hardest things about finding equipment is finding them close by. You know, we're down here in the Carolinas on the coast, wasn't historically a industrial area, so most of the equipment I acquire, I'm always going back up to hometown of New York or New Jersey, Connecticut, or out to Ohio, more industrial areas to find good used equipment. Well, started searching eBay and Facebook Marketplace and found a couple of machines. Again, like I said, the Vectrax brand wasn't on my short list. It actually wasn't on my list at all. But I remembered this machine. I just happened to go over and ride by Thompson's shop, and I walked in, and he sort of remembered me, and he actually told me, well, I called you about 15 years ago to ask you if you'd come teach me how to run the machine, and you kind of said you'd get back with me. You never did, and I lost your number, and after that, the machine just sat. Well, there's the end of the cycle there. I see it, and it always parks at its home position. But we'll run it through again while I'm running my mouth here, and the program rewound itself to the top. So anyway, when I went over to Thompson's, I said, will you still have that thing? So he took me in the back. He said, follow me, basically, and it was sitting back there with about 3 inches of dust on it. He says, you want it? Make me an offer. So I hated to make him an offer because I know he paid $4 grand for it back in 2010, and I didn't want to pay $4 grand for it. So before I said anything else, I kind of stumbled and sat there for momentarily. He said, would you give me $1,200? And I said, hell yeah. So that was the story, the last segment. Me and my buddy Cameron went over there and got it. But a couple days later, cleaned up, fired up, wired in and working. So I think we got a runner. I'm going to let it cycle a couple more times, and we'll call it a night. And like I said, I got my right angle plate up there. We're going to indicate that in and figure out our coordinates for our hoops. And we'll get to motivating. Let me show you the hoop. So for those that don't know, historically, what we've always used was wire for the O-ring. We always made them out of wire. And you'd buy that from, like, I think I got some here on the shelf in the back, like SC, oh, I know I have some back. Yeah, here it is. Cylinder head wire. So you roll this out of a wire, and you cut it with a pair of side cutter, pair of dikes, and then you fit it in the groove. Well, some smart person about a decade ago figured out that instead of using wire, why not manufacture a billet ring? So we make these in-house. This here is one for a 4.5-inch bore Hemi. It's actually way too wide, too large for this head, but it gives you the idea. So instead of wire, it's a solid billet, cylindrical, basically piece of tubing. I buy stainless tubing, 3/16 tubing at the scrapyard, and the size I need, and I put it on the lathe, and we turn it down and cut it for what we want. So the groove in the head, I'll machine that out with the end mill. We'll circle interpolate a groove where we'll sit this in, have a little protrusion, and then now on the cylinder block, I'll cut the receiver groove to receive this, and then the copper head gasket will form itself over this, so it'll be totally encapsulated. So let's say, I'm just gonna use some round numbers. Let's say the width of this here is, let's say it's 100 thousandths. So if the width is 100 thousandths here, I may cut my groove into the head 75 thousandths deep. It'll have 25 thousandths of protrusion. And then my block, I'll cut the block grooves on the block side 25 thousandths. So when you torque this head down, it's going to squeeze that in, right into the top. Now, I'm just using numbers. I'm not using the exact numbers I'm going to use. But as far as protrusion, who gave me my numbers, Alan Johnson, was nice enough to tell me he likes to use 0, meaning if this is 100 wide and the groove sitting down 75 in the head, then you want to make your receiver groove 75. Some guys use a little negative, some guys use a little positive. I went by what Alan gave me his advice to use, and we've had good results since. So that's what I go by. Before that, we would always do wire, like I just showed you. We'd cut the wire and put it in. And of course, with the wire, you still need receiver grooves. Again, now the sleeves in like the Hemi blocks, when you buy the sleeve, it has the receiver groove in it. If you look closely, so you can see the groove there. So, like I said, there's the wire on my Vini heads. This is for our motor for the funny car. And then the receiver grooves quite a bit wider than, when you cut your wire groove, you're making it, so close, you're just taking a little rubber mallet and just kind of pounding it in, getting a nice fitment there. But you see the groove, when you use wire, you end up with an end gap, like a piston ring, because you're using wire and you're cutting it. Well, with those solid hoops, now you don't have an end gap. You have a solid, replaceable billet O-ring, basically, receiver. And like I said, it sits in there. Now, some guys will put the hoops actually in the block and put the receiver groove in the head. And it just depends on what you're doing. I like to put it in the head and have the less of the depth of the machining in the block. So, as you see, I haven't gotten much farther with the Hemi. Still got a little bit of a connecting rod debacle. I'm still looking for some used rods. I haven't found anything to my liking yet that had low enough runs or low enough price. I actually thought about taking 100,000s off the deck of the piston to help bring my compression down. Again, the reason we have this problem, because I figured all my math out for that cracked ass crankshaft we had. Remember, we set this up for a 3-inch 750 crank. Crank was cracked, so I had to put my big 4-inch 150 crank in it. I say big to me. So now the motor went from 450 inches to an even 500, which is cool. All the more is better. But it moved our compression ratio. Calculating my compression ratio with that 145cc head and the 60 thousandths gasket put our compression ratio through the roof at 15-1. Way too much. Killer top alcohol motor might be around 13-1. I wanted it less than that because I wanted a nice tuning window. I was hoping to come in around 11-1. I don't know if I'm going to get to 11-1. Looks like we're going to be a little higher. Again, with this rod, if I took 150 thousandths milled off the top of the piston, I would get there to be able to use the rods I have. But after doing a thickness check on this piston, I have a sonic checker that I checked it with, but plus I was able to put my little fixture of a dial indicator on my little granite stand here. We were able to put the piston under and actually mathematically figure out the thickness of the deck of the piston, which was only 275 thousandths. So there's not enough room there to, there's not enough meat there to start whacking material off the pistons. I'd have to be spot on the tune, and really, I think 250 is about the minimum you'd want to go on deck thickness on a piston on a blown alcohol motor with 50 psi boost. So, but anyway, I just wanted to make a quick video showing our new machine, our $1,200 CNC machining center. So, just so you know, anyone could do this shit. So if you want to do it yourself, got any questions on anything, hit me up. I'd be glad to share what little bit of knowledge I have with anyone that would like to know. All right, guys, that's it for tonight. I'll catch you back up here maybe tomorrow. I'll do a little video with the machine cutting the heads for the hoops. So, all right, have a good night, guys. We'll see you later.